Good morning, everyone, and thank you very much, Toby, for the introduction. This morning, I'm going to start with something about climate change, and then I'm going to show you some of the techniques that the ARC is doing, mainly in the cropping cycles. So if we think about agriculture, we know that all agricultural production is affected by climate. So whether it's the crops or whether it's the livestock, they all need water. They can't grow without water, and we know that the main source of that water is from the rainfall. I don't want to tell you about the water cycle, but you know that we have had good rains this year, so everyone is celebrating. If we think about the different farming systems across South Africa, then we know that the division of the different farming systems is really according to where the rainfall has been falling. So according to how the climate has been in the long term. So if we think about Western Cape, we know that it has winter rainfall, and therefore certain crops can grow there. And if we think about the Karoo, then we know that it is semi-arid, and so it is more difficult for us to cultivate crops there. So it's very important that we know about these agro-ecological zones across our country. And this is what means that we have a world in one country, because we have a whole range of agro-ecological zones. So it's good for tourism, but also good for agriculture. And if we think about that, then we really think about the temperatures in those zones, and that's how we classify it, and also then the rainfall. And so we want to look today at some of the things that the Agricultural Research Council is doing. So if we first look at climate change, and as Toby said, it's a hot topic, but it's getting hotter. And if you think about it, maybe many people know how climate change is really the warming of the climate. But I want to start with the rainfall first. And if we think about our different years over the last few seasons, then we know that we've had some seasons that have been rather low in rainfall, and some of the rainfall only started in the summer region during January. And so we know there's a lot of variability in our rainfall already. But if we then feed that into the climate models, and they are global climate models, so they are explaining and calculating the climate right around the globe, and then they are looking at maybe 200 layers in the atmosphere. So if you imagine a globe, remember the globes that we usually use, then the atmosphere is only as thin as a piece of paper. So you have to get the concept of the size of the atmosphere compared to the size of the globe. So they've divided that atmosphere into about 200 different layers so that they can do the mathematical, physical calculations. And then they really are doing their very best. So here we have information from 6 different models, from Australia, from the US, from Japan, from the UK, but you can see that they're getting different answers. Now, is this because we're not good at our science, or is it because there really is a lot of variability in the rainfall in this region? So you can see that the green line is saying that there would be maybe a decrease of 30% in the rainfall. And the black line is saying that by 2100, maybe there could be an increase of 10% in the rainfall. So when we're thinking about climate change, yes, we know about temperature, but let's remember the rainfall also, because the rain is really vital for our agricultural systems. So if we look then at the temperature, so these are the same 6 models, and now we're looking at the temperature changes from 2000 up until the end of the century. And you can see now that the 3 models are really agreeing with each other. And so that's why we can be certain that the temperatures will be increasing. And from some of the latest studies from IPCC, they have really shown that a part of southern Africa is really one of the hotspots, where it will actually be increasing more than the general global average. And so in some ways that's good for us because there's some focus of attention on Southern Africa. But in the practical sense, it's very bad for us because it means that we have to really face that +2 or +3 degrees sooner than the rest of the world. So if we look over here, say by 2050, then we already have 2.5 up to 3 degrees change according to these models. So the climate scientists have really tried to do their very best by characterizing the atmosphere and building it on good, solid physics, and they do it for the whole globe. But then we also have what we call regional models. So the regional model then comes down so that it'll just do a small piece of Southern Africa, and it will have some other boundary conditions. And so that's usually what we would be using when we're doing the current situation in South Africa. So if we look and know about Southern Africa and East Africa, then we know that there's high variability in rainfall, there's a frequent drought. Of course, we must know that a drought doesn't mean that it's not raining. So there's a difference between drought and a semi-arid area. A semi-arid area means that there's always a low rainfall. But a drought means that it's less rainfall on that particular time period than you would normally receive during that season. And so the Agricultural Research Council has been developing some tools and different techniques, and I want to show you in 3 sections. First, a little bit around biological control and disease monitoring, then some environmental monitoring, and some operational activities. So if we start with the biological control and disease monitoring, a lot of this is done at Plant Health and Protection Institute. And I apologize, this is not at FOPI. So this is one of the biological fungicides and pesticides, and there has been a commercialization of this product, and it is a fungal contact insecticide, and it's for to reduce the populations of the target pests across many of the crops. There's also many others that are also being developed or have been developed by this institute. If we go to the ELISA kits, then this also is something that we need to do, because when we are trying to detect what kind of diseases are present in the field, we really need to have a simple kit that we can actually see which of the diseases are present so that we can only treat those diseases. And this is also used in the breeding sector, so they need to be able to be sure that there is a disease-free community so that they can breed with that. So this is the 2 diseases, tomato spotted wilt virus and cucumber mosaic virus, and these are diseases that don't only affect those 2 crops but also some other crops. And so the plant breeders can use these kits to be able to screen for the presence or absence of the disease and be able to test the genes for disease resistance before they go ahead with their breeding program. There's also some other diseases that are quite bad for humans, and some of them are the ear rots or the mycotoxins, and they can occur during the storage of the grain, and yet they have a very bad effect on humans and on animals. And so Dr. Belinda is doing some of this work at Potchefstroom at the Grain Crops Institute, and they have a number of training programs, they have a number of awareness programs and projects that are really looking at the different management practices to be able to reduce these fungal diseases. And this then is helping to improve the quality of life of the people and also to increase the opportunities for grain export. Together with this is also some root rot monitoring, and the root rot, of course, is a severe disease that would affect the production of the different crops. So let us go over to the environmental monitoring. And one of the speakers earlier today, or even yesterday, was talking about the fact that we will go from monitoring at a block level or a farm level down to a block level to maybe a row, and then we can go to a single plant. And so that's what this system can do. It's being installed at Grain Crops Institute in Potchefstroom, and it is funded by the NRF National Equipment Program, and it has a sensor that they call the plant eye. So the plant eye has a resolution of less than 1 millimeter, and so you can do the computations every 2 hours. So this is what the instrument looks like, and it will be across a field that will be planted with the crop, and then be able to monitor it from three-dimensional perspective, and be able to then look at the different wavelengths, and from that be able to tell what the growth is about, or what is the biomass accumulation, or what leaf area or leaf angle. As we know, some of the maize varieties now have the erect leaves and not the flopping over leaves, and this has been shown to have higher radiation use efficiency, and so that means that especially the ultra-short maize varieties will be able to produce more. And so this instrument is being commissioned in Potchefstroom. And now, well, everyone was showing videos. I don't know how to get it to go. Anyway, it is just showing you how it can look at one plant at a time. So if we think about the environment, then we know that if we're going to do environmental monitoring, we need to look at the Internet of Things and be able to see what are the unique identifiers of that specific piece of instrument. And some of the other speakers have been showing some of the operational things that they can do, and we need to be able to then respond to that information. And so it doesn't help to only be able to measure it, but we also have to be able to respond to it and have some kind of an action that the user can program. And when we're thinking about that, we need to think about a time scale and also the spatial requirement. And so that's where we can look at some of the opportunities in the environmental monitoring. So firstly, we would look at the automatic weather stations. The Agricultural Research Council has more than 500 automatic weather stations spread across the country, and many of them have many years of weather data. The data is monitored and collected in 5-minute intervals and then saved in an hourly basis, and this is then available for the other operations. So in order for the automatic weather station to work, we have to have a data log communication system and also power from the solar panel. So we're measuring the temperatures and humidity with a thermistor, rainfall, wind speed, and wind direction. Other monitoring in the environment in the field is also with the soil water probes, and these can be at different depths, and this chameleon sensor is from the Virtual Irrigation Academy at University of Pretoria. If we're trying to look at irrigation and optimization of water use, because the water is limited, then we need to know how much water a single plant is using. So this is a lysimeter that is a box of soil, and the plant is growing in it, and then it can measure all sorts of soil water and temperatures of that plant, and it has a weighing mechanism to be able to work out how much water has actually been used. Another way to measure the transpiration is using sap flow probes, and mostly these have been used on the tree crops. If we want to look at the whole field, then we can use this eddy covariance system, and this is again measuring the crop evapotranspiration, and it then takes into account the whole field. It takes into account the wind direction, and whether there's advected heat coming from any area, and this is being done at a Ridderplot at the FOPI Institute. That information can then help us to calculate a KC value, which is our factor to be able to work out how much irrigation is needed for each one of the weeks or days for a particular crop. So here you can see that it's against the time period called growing degree days. So this means that we can take into consideration the increase in temperature because of climate change and be able to calculate a new KC value. Here is another one of the projects, and this is on the irrigation of barley, and it is sponsored by AB InBev. We've seen outside there in the displays, there's some nice drones, and I wondered whether they were going to fly one of them for us, but maybe not. Here is the drone that Agricultural Research Council at Institute for Soil, Climate and Water has purchased, and they have two main sensors at the moment. One is a multispectral sensor, and the other one is a thermal camera. So we use the thermal camera to be able to detect whether there's a disease infection or whether there's a need for irrigation. And we also have two people who have now been trained with a drone pilot's license. So these are the kind of images that we can get for a research basis for this. And these are particularly on the left-hand side is from the peat fires that are burning in the northwest. We hear a lot about the fires burning in Malaysia and Indonesia, and we don't realize that it's right here on our own doorstep as well. And so as soon as the wetland is drained, then it's now almost got some wood that's there, and so it can actually burn. And so this is, of course, a big problem, but here we're using the drone to be able to detect the temperatures at the surface. Of course, we can use the drone images to be able to compare with the satellite images, which we have been using for a long time, especially the NDVI, which is the indication of how much green plant material there is. But if you look in the right-hand side corner, you can see the two images of the same field, and there's quite a lot of more accuracy and precision when you're looking at the drone values, and so that can be on a smaller basis. I spoke about the Agro-Ecological climate zones, and this is maps using the outputs from the global climate models, and so it is taking the top right-hand side is the present-day situation of those climate zones, and then going down and looking at how they will shift through the century. So you can, if you look at some of the green parts in the present day and then compare it with at the end of the century, you can see that there's quite a lot of difference. The way we can interpret this then is that we can take it and use it to work out how the area where the crops are growing will be changing. So if we look at the left-hand side is from 2015 and look at the dark green periods here and go to 2090 and see where the optimal areas would be for the maize to be growing. This is also possible for the other rain-fed crops, and so there's been some suitability maps also made for barley and for the irrigation areas around Valhart and into Limpopo province as well. So let's look at some of the operational activities that are also available, and I've talked a little bit about the drones, and these are then available for specific tasks and to answer specific questions. And so that is really taking the applied research and giving the farmers some answers. There's also opportunity for microdosing of the fertilizer or pesticides, and this can also help particularly the small-scale farmers. If we think about precision irrigation, then we've seen some of the applications already, and it can be about scheduling the amount of water to apply. It can be about really placing it in the right place. So if you have microjets or micro sprinklers, then you would be able to only turn on certain parts where, say for an example, in an orchard, particular trees need more water than others. And so this can really be controlled in an integrated way with the weather station, because the weather, automatic weather station will be telling us the evaporation rate over the last day and since the previous irrigations. If we're going to do some of this precision agriculture, then we need to have some things in place. And it was good that the gentleman from Vodacom was speaking just now, and so some of this is what they are providing. We all know about GPS. We need to know where the position is in the field, but we also need to have a GIS with the different layers of all the information about that particular field, so the geology, the soil, all of those kind of information, so that we can actually then do the operations in the correct way. As I said, we want to be able to use that information to make some decisions and to do some activities, and that would be using this variable rate technology. And I've already described the satellites and optical satellite imagery that can be used for guidance for those management decisions. So from the Institute for Agricultural Engineering in Silverton, they have been developing a homegrown South African weed detector, and John Deere was telling us about some of their operational systems, but here this is homegrown in South Africa, a weed detector that can use ultrasonic and infrared beams to be able to see which should be sprayed, and so that the spray doesn't actually go onto the crop itself. Another one of the activities is the recirculation hydroponic system, and so there's been quite a lot of information about vertical farming, and probably many of you have seen in the supermarket you can buy the lettuce that still has its roots on. So these are mostly coming from these vertical systems, and it is really increasing the water use efficiency and therefore being able to produce a better crop with less inputs. So let's go across to the mobile information services. As you know, we have fairly good coverage across our country, but obviously some of the systems are not really into the rural areas. But if we're looking for the farmers, then we can provide localized information, and we're using the weather forecasts at a 15-kilometer radius. And we can provide information that is updated every day, and we can also provide it in the local languages. So if we look at two examples, one is the agricultural ARC hub, and this is giving agricultural production information for the farmers, and they are able to look at what crops can grow where and be able to access some experts as well. So you can choose your crop, and then you can get the information about that crop, and it is available for download. Another example is the mobile app AgriCloud, and this is helping to take the weather information and add some expert knowledge about the crops, and they'll be able to give some advisories to the farmers, and so it's tailor-made for the specific farmer's needs, and it is giving them information on a daily basis. And this helps to reduce the weather and climate risks. And this AgriCloud is available so that you can register for a specific location and really pinpoint where your farm is. And then, as I said, it's available in the official languages. So even if the extension officer or an advisor doesn't speak the language of the farmer, they would be able to get that information and show the farmer in his own mother tongue. The information is updated on a daily basis, and it's taking the weather forecast for the 10 to 14 days, and then being able to give you some information about planting and also about spraying for pests and diseases and spraying of herbicide. So this is really going to help the farmers in those decisions. So basically, we're taking some weather data, we're taking knowledge engines, putting them into advisories, and then it can be in a report via a portal, by subscription, or it could be on your mobile phone, or it could be as an API service that you attach as a button to your own website. So these are the kind of things, and there's opportunities to be a client or a partner for this service. So in conclusion, I want to say that there's a lot of research that's going on around looking at what are the effects of climate change and how can we approach it from different areas for the crop production in this country, and really to be able to go all the way and help the farmers address some of the agricultural drought, the increase in pests and diseases that would come about because of climate change. And this, of course, is really using some of the smart technology and the 4IR to really combat some of the adversaries that we are faced by climate change. Remember, increase in variability of the rainfall and a definite increase in the temperature. And so I believe that we can really, from our research side, assist in some of the services to agribusiness and to a full range of farmers. And so in conclusion, I believe that there's a lot of research that's going on, but we need to be able to take hands, we need to explore together, we need to be able to create together with the farmers, design what is something that is needed for them, that can fill that gap and answer their questions, and then redefine and be able to come up with a good solution. And I just want to acknowledge the various institutes because they contributed to the topics for this discussion this morning. Thank you.